This video is to allow you to correct your homework for section 2.2.4. So they want you to find the value of each expressions. Not able to use a calculator, obviously. You can use a tile diagram, which would be the positive and negative tiles, or a number line to help you if you need it. So this would just be 3 times 4. Remember, a number in front of parentheses without a math operation sign in between means multiply. So 3 times 4, of course, is 12. Here you could do this on a number line, or you could put 4 positive tiles, 11 positive tiles, 4 negative tiles. We can see that the 4 positive and 4 negative would create 0 pairs, so our answer would be 11. But again, you could show that on a number line as well. Here we're just taking 3 and 2/10 times 2, so that's 6 and 4/10. Negative 2 plus negative 2 plus negative 2 is negative 6, but again, the absolute value bars tell you that we want to know the distance from that negative 6 to 0 on the number line. In other words, 6 units. Remember, absolute value bars represent distance, and the answer is always going to be, once you apply the absolute value bars, positive. Here you're taking 2 times negative 7 and 5/10. Well, 2 times negative 7 and 5/10 is negative 15. And then again, once you apply the absolute value bars, positive 15. Here you may have to show a little bit of work. A couple ways you could do it. One is you could take 10 times 5 and 1/5 times 5, apply the negative. You could also change 10 and 1/5 to 51/5 by changing it to a fraction greater than 1, and then multiplying it by negative 5, which can be written as negative 5 over 1. You could simplify the 5s. Dividing them both by 5, you'd get negative 1 here and 1 here. So final answer is 51 times negative 1 over 1 times 1, which is negative 51. Here they want you to use the distributive property to rewrite them and then calculate the value. So 9 times 410 can be broken into 9 times 400 plus 9 times 10. Well, 9 times 400 is 3,600. 9 times 10 is 90. Combining those together, you get 3,690. Here we'd break this apart into 6 times 500 plus 6 times 90 plus 6 times 2. 6 times 500 is 3,000. 6 times 90 is 540. And 6 times 2 is 12. And then you combine those three to get the final answer. Here they want you to use the diamond problems, and they remind you in this diagram that the two values on the side, the x and the y, get multiplied to give you the top. So when we have x, y right next to each other, no other math operation in between, it means multiply. So we're going to take these two on the side and multiply to get the top. And then we can see on the bottom, we're going to add them. So when you're trying to figure out what the missing number here on the right is, you have to say to yourself, well, I know 9 plus this missing number equals 16. Well, then the missing number must be 7. And then I know I'm going to multiply the 9 and the 7 to get the top number, which would be 63. Here you're saying to yourself, what do I add to 8 to give me 15? So that would be 7. And 8 times 7 is 56. Here you're looking for the two values that would multiply to give you 49 and add to give you 14. And that would be 7 and 7. And here, if you took 2 times 1/2, 2 times 1/2 would be like half of 2, which would be 1. You could also show it by putting it as 2 over 1 times 1 over 2, and either simplify before you multiply or multiply then simplify. And when you add 2 and 1/2, you get 2.5. Now I changed to the decimal format just because it was easier to do on a keyboard. Here you have to complete your portions webs. So they're giving us the words and the decimal. We need fraction and percent. So 45 hundredths is the same as 45%. And as a fraction, it would be 45 over 100. But remember, we need to simplify our fraction. So what we want to be asking ourselves is, what can we divide both 45 and 100 by, other than 1, so that we can get it in the simplest form? Well, 45 and 100 will both divide by 5. We know that because one ends in a 5, one ends in a 0. So 45 divided by 5 is 9. 100 divided by 5 is 20. So 9/20. Here we have the fraction, which is greater than 1, and the percent. We need decimal and words or pictures. So the decimal, when we want to change from a percent to a decimal, we move the decimal point 2 places to the left, and we drop the percent sign. So 1 and 27/100. And then in terms of words, we would say it as 1 and 27/100. Here, Camille had this fun birthday party. Lots of family and friends attended. The party lasted for 3 hours. They played games for 3/8 of the time, ate pizza and cake for 50% of the time, spent the remainder of the time opening presents. They want you to draw a diagram and make calculations to show the amount of time opening presents. So, what I did is this. I changed the 3/8 to a decimal, which would be 375 thousandths, which if I move my decimal point over 2 places to the right, I get 37.5%. And the reason I did that is because they'd given me this as a percent. So I thought, let's convert the 3/8 so that it's also a percent. When I combine those two together, I get 87.5%. Well, if 87.5% is the time that's spent playing games and eating pizza and cake, then I can subtract that from 100% to see what percent is left to open presents. And that would be 100% minus 87.5% is 12.5%. Then when I want to take 12.5% of 3 hours, I can change my 12.5% to a decimal, which again means move the decimal point 2 places to the left. It's a bit messy, I apologize. Of we know means multiply, and so you're going to multiply. So then you get 1 and 125 thousandths hour. Now, another way you could have approached it is you could have changed the 50% to 1/2 and got a common denominator and subtracted. That would give you an answer that would not be a decimal because this is actually equivalent to 1 1/8. Another way you could do it is, as they talked about, drawing a diagram. Maybe show a whole circle for the 3 hours of the party, and then show 3/8 of that circle being used up for games, half of that circle being used up for eating pizza and cake, and then figuring out what percent or what portion of the circle is left, which again is 12.5% or 125 hundredths or thousandths, pardon me, and then figure it out that way. So there's a lot of way, but make sure that you're showing your work. Here, Jana measured the heights of the sunflowers, and these are what she found. So they want you to find the mean and median. Again, for work, I want to see that you added them all together and divided by how many numbers are in the list to get the mean. And I want to see that they're in order for you to show me how you got the median. Then you need to make a histogram with this. So to make a histogram with this, you should have 4 bins, they're telling you, with a width of 15. So what that means is along the bottom, we're going to go 30 to 45, that's a width of 15, 45 to 60, 60 to 75, 75 to 90. So those are bins at the bottom. And again, we need a label on that, which is the height in inches. Frequency, remember, means how many times it occurs. So how many values are between 30 and 45? Well, there's the 34, and let's see, where's the other one? 39. So because there's 2 of them, that's why the bar height is 2. Then how many are there between 45 and 60? Well, we got 48, we got 52, we've got 56, and that looks to be it, which is why our bar height is 3. Now, remember, with a histogram, the bars are going to touch. So for a histogram, we need intervals or bins like this, and we need to have the bars touching. Anyway, you're going to continue that and to fill in the other 2 bars, and that's what gives you the information for the histogram. I would also say that this histogram should have a title on it. Something like height of sunflowers growing in Jana's backyard or something like that.